Good evening, everyone. I'm Ewan Benyon, Master with CalMac. Joining me tonight is Dan Barton, he's Chief Engineer. He'll do his little introduction shortly as well, just to do the icebreakers. So I think probably we've named this one Connecting the Islands. However, I think the previous name in your arena slides of for how it affects the end users is probably more where we're going today with this one, which will hopefully be a little more interesting. So what we're going to just go for the next probably 35 to 40 minutes or so, a quick introduction to Dan and myself to begin with, a little introduction to CalMac, Caledonia McBrain and CMAL, which is confusing for a lot of people, including sometimes some of us internally as well. A little bit about the vessels and port types, deck operations from me, engine operations from Dan, and I think in the poster we said a little section at the end on input into vessel and port design, but we're probably, as you'll see as we go along, that'll probably come into the slides as we do it, so a bit more combined on the whole thing there. So whilst it's me to begin with, I'll introduce you to myself first and then hand you over to Dan. So I started, it's just 21 years in the industry, not all of it at sea. Started in 1999, Millennium Cadet with Maersk Line. This was predominantly container ships, but also LPG tankers and some offshore as well. I moved across to Ferries, North Line originally there, which were under the Maersk umbrella. Started with some new builds out in Korea for the cross-channel service. So that's where I honed my my ferry experience. After a little, probably about 6 years there, ended up responding to a British Antarctic Survey advert. Did a couple of years with them. Very interesting job. Some of the conditions that you can't imagine, the sort of things in movies at times, perfect storm, but very rewarding, interesting job, but very long time away from home, and one that wasn't going to be a forever job for me. From there back to Norfolk Line, who'd become DFDS by then, some more ferrying away, and then after that, one of the guys I met in the Antarctic Survey, and we did some dynamic positioning there. He was assembling a team offshore. That took me out to P&O Maritime, not particularly well known in the offshore industry. A vessel that was a bit of a jack of all trades, master of none. Needless to say, it wasn't a great job, didn't last there too long. But then found myself ashore for a couple of years with Braemar Technical Services, doing surveying, accident investigation, insurance, warranty, various work there. Actually did a couple of presentations to RENA, your London branch, container ships and offshore vessels, I think there, but not sure if any of you will have seen those. And after a couple of years of that, again, very rewarding job, learned a lot, but unfortunately a big percentage of this was aircraft, the interior and airports. So that wasn't a job for life either. But now at CalMac, 6.5 years in, as master, I found myself in the office again, probably a bit more along the lines of the Braemar job. So Dan and I have been doing some subject matter expert, I think would be the official term, kind of to assist with introduction, various projects, but predominantly introduction of new vessels. And we'll come back to that later on. So Dan, I'll let you jump in there for a wee bit.
All right, thanks, Ewan. Yeah. I'll keep mine quite brief. I've got a slide later on, which is a bit more of an introduction to myself. But yeah, as it says there, 24 years in industry, went to sea in 1996 with P&O Containers as a cadet. I did just over 3 years with them, qualified on worldwide container ships, old vessels, new vessels, had a great time. I did 4 years on United Marine Aggregates, aggregates dredgers, trailing suction hopper dredgers, which was great work. I enjoyed it. Totally different to the work on container ships. One thing I found out when I got into small vessels is I'm not actually a very good seafarer. When the weather starts getting bad, I'm going to get bad. So that was something I learned when I went on ships that were less than 200 meters in length. went for an interview with CalMac, and I've never looked back. So that was 2006, and I'll talk a little bit more about that later on. So yeah, you happy to carry on, Ewan?
Brilliant. Cheers, Dan. I'm on two screens here, so sorry I'm looking away at times. There we are. Right, so back to what we do. So CalMac operating 36 vessels in total. These are owned by CMAL, and effectively we're probably known as a public sector company. However, CalMac Ferries itself is a private company. We operate the Caledonia McBrain Ferries brand, and this is basically, at the end of the day, the public sector side of things comes from government tendering, which we have for 8 years on the Clyde and Hebrides ferry service. That means a subsidy within that period, so that brings us in very close to communities and governments. So there's a lot of people involved there. Operating over 50 ports, 22 of the major islands, and in over 163,000 sailings annually. So if you add the berthings to that, each sailing add a manoeuvre at either end, it's quite a lot of manoeuvres a year. So that's a large part of any ferry industry, but particularly for us. There's some employment figures there as well. We operate the Lifeline service, which you'll hear often, depending on whose interest this is, what the level of Lifeline is. Sometimes that could be commuting to some. So, as I mentioned, lots of interested parties there. So stakeholders, government ministers, haulage companies, island communities, tourism. Everybody wants to say into what's going on with CMAL and CalMac's work. Expectations from the public with the government subsidy. There's a feeling that it's public money, so everybody likes to keep an eye on how it's spent. More and more commuting these days from the islands such as Arran, Bute and Mull. So we have to fit in with public transport network on a wider scale. Obviously the enthusiasts with any type of transportation, Clyde River Steamers Club, very interested, very supportive to us most of the time. Other maritime groups, sometimes less supportive, and you're always being watched on social media, which is an interesting thing sometimes when your master and your ship handling isn't up to scratch because you're a little bit rusty. So you appear on Facebook before even you've told your marine manager what's happened. Oh, sorry, sensitive mouse. So we operate our large group of vessels predominantly under two sections, major vessels and small vessels. It tends to really be the type of certification required that comes with sizes. Full master's tickets for large vessels, boat master tickets for some of the others. So up here in the top left, you see the largest vessel we operate, which is the Loch Seaforth, 117 metres. Going clockwise then, the Argyle, that's previously was intermediate, but that's come under the major vessels now. Much smaller, that has shuttle unit propulsion forward and aft. We go round again to the Argyle Ferries. Smaller vessels, they've just recently come under the Caledonia McBrain livery, but been managed and operated by CalMac for some time now. And the large Katrina in the bottom left is a small fleet, so that's a boat master's tickets. Large vessels tend to operate to link spans, small vessels tend to operate to concrete slips. So a lot less port infrastructure. Some of the remote small connections made by those ones, and you can see there's a very big bow ramp, and that's to deal with the inclination of those slipways. So on board, we tend to have three departments. You've got myself representing deck tonight, which is master, a chief officer, and officers of the watch 1 2. Predominantly navigation of the vessel, also cargo operations, life-saving, firefighting, maintenance. You have the engine department headed by Dan, the chief engineer. He's a second engineer and engineer and officers of the watch as well. That's all the marine machinery engineering, as you'd expect, maintenance, repairs, and basically keeping the ship running. And then also retail, so onboard services or chief steward, and a selection of senior catering ratings. And that's, for us, that's potentially where we can make some money as a company when we're operating to sort of subsidies, and obviously offering reasonable prices on crossings that we do. So quite an important part, and I'll touch on that with vessel design shortly as well. So starting with the deck side of things, deck officers will primarily be in navigation, as simple as driving the ship from A to B. This starts with learning traditional methods of position finding. We do still learn how to find our positions from the sun and the stars using sextants and tables. However, obviously electronic nav aids are so much better these days. So we obviously use these predominantly. But we do, however, learn the limitations on these. It's not always as easy as just your Google Maps. There's times when signals interrupted, atmospheric conditions, all these things that we have to be aware of and make sure that we're always finding different ways to confirm positions so we don't end up aground. Merchant Navy is very different to the Royal Navy. You probably find when a merchant vessel's out on passage, there's one person on the bridge, one officer of the watch. Once you get into restricted waters, you probably have a helmsman. We do still, in restricted waters, have somebody steering by hand. That's the best feel and the quickest reaction, and we like to think the least chance of error. And of course, once we get into the berthing parts, that's generally where the master's always on the bridge with the overall responsibility for what's going on. There is movement now towards autonomous vessels. You'll be seeing it. You'll probably be more aware of it than me in some regards. It's quite useful, this. It's obviously crewing costs are one of the biggest parts for ship operators. And if you can reduce this, that's great. We recently visited in Scandinavia one of these vessels, an auto berthing, and it is impressive. It's still slow, and it tends to be reactive. So it responds to the wind it feels. So you might program in a start approach position, and then the vessel will get itself there and then work out what it has to do. So from a pilotage side of things, that can often put you in the wrong position. So there's definitely some worth in our existence for the future that we will have to sort of program anything like this to learn pilotage and how to go about ports with currents and that foresight and pre-planning. So we're not redundant yet. Bridge operations, of course, there's traditional charts originally. As I mentioned, there's one officer of the watch on the bridge. So this means that bridge gear over time has become more and more integrated, so everything can be operated from a single operator's position. You'll even find now that radars overlay onto electronic charts, and it can be quite an information overload. So despite all this technology, and it is advancing at some rate, it was left behind the aviation industry for years, that's for sure. Catching up very quickly now, limited amount of standardization from the industry as a whole. So this allows the fast advance of competition between companies, primarily in software, but it does mean that some of these get very, very complicated and there's a lot more than what you need. So you're starting to see that creep into a lot of the accidents and incidents you see. So there's an element of keeping it simple. The other big part for the decorations is the mooring. This again, there's auto systems and things coming into play. That's very expensive, particularly when you've got a lot of ports around your network, all different ships. You need different ships to all fit in the same ports. So there's a lot of operational challenges to auto systems. So that's why it is very traditional still, the methods of mooring, and it's very labor intensive. You can see there in the middle picture on the forecastle 3 crew members. You probably one of those for visibility, one to operate the winch, and 2 of them running lines at the same time. The picture to the right is an aft mooring station on one of the larger vessels. So you've got 1 capstan and bits. So I'll come back to this, the reason you have this small marine deck later on, but that obviously is quite limiting in what you can do there as well. So marine's a big part, particularly for us on the Western Isles. And I will also come back to that later on. Vehicle and mezzanine decks. So cargo operations is obviously a part for deck officers as well. Limited to the size of vessels that we can have here. This is, CMAL can confirm that. There are lots of requirements to fit into a very small space. And because the way the nature of our operation on the West Coast is we carry freight, but particularly in tourist seasons, the car numbers increase considerably. So what you can see on the left here are hoistable car decks, or mezzanine decks as they're quite often known as on the ferries. On the left-hand side, a single lane. On the right-hand side, in the stowed position, a twin lane. And you have a gap in between, which allows for some high-sided vessels, high-sided vehicles. And then if you look at the picture on the right, a big problem these days is a lot of the old vessels were designed for cars which were much smaller. So as cars get bigger, I often say that if you look at a Mini these days, particularly the width and with all the safety features, it takes up a lot more space, and we find the numbers we used to be able to carry are now harder to achieve. But in this picture, you've got quite a nice space there, a nice relaxed load, you're not full. Again, you can see the mirror decks, quite small, quite limited again. So this is kind of just going back to what I said there, when you have the general arrangements come out and you try and plan for how many car units you can carry. So if you look at that top, it's a relatively old general arrangement now, but you can see cars right up against the side, no space for opening doors, people to get out, space in between them, lack of swinging room to get in and out of position. So you find that you tend to go on the side of caution with new designs. And I think certainly from what we've seen, vessel designers these days, they are making more allowance and not trying to push these coordinates too high to begin with. And for our guys, it's as simple as the picture in the bottom, that once you've done it a few times, you know, and it's just a China graph pen to decide how you're going to fit everything in. Dangerous cargoes. Becoming more and more of an issue for us. More of them around, for starters, more and more chemicals being created every day, year. And as a lot of these become more and more hazardous for us and the type of vessels we operate, from the construction side of things, it's very difficult to carry a lot of these dangerous cargoes, and a lot of them are carried under exemptions because of where we are, and we are the only option to get these things to the islands. This tends to drive the design of these open back ends, which you see in the picture here on the Lord of the Isles. And again, with that height requirement that you can see now, if you want to get four articulated lorries that are carrying dangerous goods on that back end, you haven't got a lot of room for your mirror decks. A couple of our routes, we've got the Caledonian Isles. If you know, it's on the Arran Run, fully enclosed. You get a great marine deck aft with winches. However, she can't take a lot of the dangerous cargoes, and they have to go on the back way, as we say, with one of the small vessels from Loch Ranza. Foot passengers. So on the left, we've got passenger access, or PAS as they're often referred to. This probably come from the cruise ship industry, very nice for connecting passengers between the office and the vessel without getting wet, blown away. We tend to have these on the busiest commuter runs at the moment, where the passenger traffic's a lot higher. If you go out to, and also you have the connections with trains, buses, etc., more frequent, so that tends to drive foot passengers up. If you go out to more remote locations with more infrequent buses, 1 or 2 a day, it tends to be mostly car traffic, and there we can do more with these the gangways, which you can see on the right. Passenger access systems, for the design side of things, it's making sure something would be referred to as the PAS window is checking the alignment of and the range that these passenger access systems can operate for all the doors of the vessels that need to go there. So very challenging, and the gangway, although it looks simple and not too glamorous, is actually very versatile. The one difference here, of course, is where the machinery for lifting is located. So the passenger access system, the motors are ashore with the system. With the gangway, you've got to find somewhere and way of putting a lifting davit on board the vessel. And accommodation and facilities, as mentioned before earlier, this is the sort of the money-making part, really. Some of our vessels can accommodate up to 1,000 passengers, and if you're on a short crossing, this means not a lot of time to serve a lot of people. To get everybody served, you need more services, more facilities, which means more crew, which means more accommodation for crew. So there's a big balancing act there. As far as designing the vessel goes, this actually can be something that in the past may have been an afterthought, but these days is required so much earlier on, because, as you can imagine, trying to fit in lots of passenger requirements afterwards can be quite challenging. So that's the sort of introduction to the vessels. And I'm probably going to go maybe slightly off piece, but hopefully a bit more interesting certainly for naval architects such as yourselves now. A lot of the master's job is quite important. It's a management job. It's budgets, KPIs, disciplinaries, stuff that's not particularly interesting, and I'm sure, you know, particularly not to yourselves. So I'm going to go a little bit more onto the one part that is interesting for a master, and that's the ship handling. So this is a little bit less CalMac specific, although used at CalMac, but sort of relevant to ferry handling. So with the kind permission of CMAL here, I've used one of their graphics, which is much finer than anything that I could produce. And I'm sure a lot of you have seen this picture, the 6 freedoms of motion, or quite often known to the mariners as degrees of motion. Science or art, as ship handlers might say one or the other, or a bit of both, and I'll work towards that shortly. But the 6 degrees of motion obviously are influenced by external factors, but we can also affect these with propulsion on board the vessel. As far as sea keeping goes, you know, for comfort of crew, passengers, security of cargo, these are quite relevant, and we can only do so much for them. So on passage, what can I do for these? I can dampen motions by ballasting. I can alter the speed course to incidents with waves, and I could deploy stabilizers of some sort to soften the roll. All very, you know, the best you can do, and you guys will know a lot more about sort of the seakeeping studies than I do. I just find the ways to try and make it a bit more comfortable. Then we've got propulsion, which can affect some of these, but that tends to be only the ones in blue. So I've coloured pitch, heave and roll in yellow here because they're limited what we can do about it, but surge, yaw and sway are the ones that we tend to affect with propulsion. So if you think about what causes these, the external elements, and I'm going to keep it 2-dimensional, there is a bit of vertical force to these sometimes, particularly waves, and you can find yourself in a situation where you could have wind, waves, current, all from the same direction, probably the most simplest. You can have a combination of both, of all 3 from different directions, that then makes it a game of vectors and balancing. And this is quite, I think this is why I've come onto these, it's quite interesting for you for the ship design side of things. When you have tunnel thrusters, so if you look at, I've coloured the force that you can apply opposite the wind in green there, and of course they can only go athwartships 90 degrees to the ship. So if you then introduce waves, current, or even the wind itself not beam onto the ship there. You've got to combine your tunnel thrusters with your aft propulsion to come up with a way of balancing these, and particularly when it comes to, which I'm going to move on to now. So you may have heard terms such as wind holding, crabbing, and station keeping. Station keeping's probably come from the dynamic positioning side of the industry offshore. So basically, you want to be able to hold this vessel against the conditions for a measure of ability. Offshore, that's keeping the vessel in position for rigs, for divers. For ferries, station keeping itself, it's not so applicable because you don't want to keep a ferry in one place. You want to get a ferry to a berth. So it's sort of understanding limits. If you know you can balance a limit of 50 knots, you know you can't berth necessarily in 50 knots in a certain method, but you could probably berth in 45 knots. So getting a little bit technical for us simple seafarers here, this would be a conventional vessel, and we'll keep it simple with just treating it for wind on the beam, worst case scenario. And basically it's a sum of equaling the wind. So you've got a wind pressure on the vessel, you need to give the same back to be in a position where you're station keeping. Tunnel thrusters forward, acting at one end, and then your aft propulsion. Now down aft with a traditional vessel, twin screw usually for ferries. You can see I've done the rudders with blue. So the only thing I can do with those engines down aft and rudders is put a rudder over to create some transverse thrust against this wind to give the back end some push. That obviously doesn't go completely at 90 degrees with a rudder over. Some of it gives you some athwartships movement. Some of it starts to push the vessel ahead and creates a yaw in motion. I cancel this out by running the other engine astern to balance it, and usually needs a lot more astern because most of the time propellers have got a head bias for efficiency on passage. So what you can see here is to balance it out, and obviously there's a center of flotation as well, so to keep the vessel on a head-in, there's a game of torques between fore and aft around this as well. So often you find thrusters in the past have been underpowered. It's quite common now to find that thrusters overpower the stern because of this sort of arrangement. But the big thing with the conventional ship like this for pushing a vessel sideways or station keeping is there's a lot of power being used down at that aft end for not so much athwartships motion, so it's quite inefficient. Ways to address this, which creep into the ferry sector and the passenger vessels more so, are azimuth thrusters. Again, you can't quite put these 90 degrees on to move the ship athwartships, and there is a balancing of the two to cancel out the forward or head motion. But here you could see, because you can apply that power in a precise direction, it's a lot more efficient. You do see other options as well where you find thrusters at different ends of the ship, more so on your double-ended ferries, which are more suited to more sheltered waters, shorter crossings, etc. So a little bit to think about, and this kind of stuff doesn't really get mentioned in building rules. So this is the kind of stuff we're coming to the end user to see what you actually want the vessel to do. This is where this is quite important. That was basically the way to push a ship sideways against the wind, but that's not the be-all and end-all of berthing. If you're beam onto the wind, you obviously experience the highest force and wind load, but if you can get the vessel bow or stern into the wind, it's a lot smaller area. One way of doing this that somebody came up with many years ago was to create a roundhead to put the vessel on so that you can approach and begin with the vessel to head in for the wind. This allows you to start getting some of your mooring lines out, move the pivot position, which you would have seen just now, to bring the ship round onto the pier, And you basically, in this situation, you probably can find a way of berthing in much higher conditions than you'll have seen just now. But obviously that involves infrastructure as well as vessel. From the vessel side, we're going to talk about belting now. So Robin strake is traditional boat building term for this sort of thing to protect the hull. You sometimes hear us fendering. Not so keen on that term because it's more of it can cause confusion with piers. And belting tends to be the ferry term that's come from probably double-ended vessels where the belting continues right the way around the vessel like a continuous loop, and therefore belt. You can look at it different ways. Sacrofill to improve hull appearance. You only get the rust where the belting's touching, so you get a nice line of rust rather than patches and smears down the hull. Protect the hull from indentation or even worse, piercing penetration and going out of blast. But the one thing that you have to consider with belting so often is the infrastructure. Some of our ports are more tidal than others, and you can see here the Clansman has these 3 layers or 3 levels of belting, and particularly forward, and this is to do with when she's out at the more exposed places such as Cole and Tyree where there's a lot of swell. She finds that she has to use the roundhead in the last picture much more often. Then at the tidal range, the movement from the swell, and that's why she's got the extra layers of belting to protect. And the other thing for berthing and manoeuvring without giving you too much of a ship handling lesson is the type of piers you operate at. Many of the West Coast ports are positioned in locations suitable for shelter, discovered by people in the steamer days many years ago, but often being at the top of locks and sheltered waters, meaning that they're quite narrow and quite shallow. So this can affect, again, the type of manoeuvre. Different types of propulsion can be more suitable for different routes. And again, it's something that's not in build regulations, but you have to investigate for the end user. So berthing the vessel is one thing, getting it there, you then need to be able to hold on. What's the point on having all this power in your vessel, getting it alongside, and then when you want to switch the engines off to save fuel, you can't stay there. So this has probably over the years had limited research, with probably ship's masters saying it's a windy day, I'm just going to throw out more and more lines and hang on. And nobody's ever really sort of thought about what this actually means for the strength, the forces in the ropes, the bollards on the vessel and on the infrastructure on the pier. Probably particularly over the last 10 years or so, 2 sort of institutions have looked at this more. The Nautical Institute, particularly for the passenger vessels, but a great deal of work has been done by the OCIMF. That's Oil Companies International Marine Forum, and the idea they're thinking there is tankers, particularly in ballast, when high out of the water and there's a lot of windage. So there's high wind loads, high forces on the ropes and the fittings. They've probably done a lot of this research because the money's been available in oil, and it has probably crept into the other areas of the industry as the go-to guide now, particularly for high-sided passenger vessels, high-sided container ships. I'm not trying to plug here. I'm a member of the Nautical Institute. They do a lot of good work. But one way to come around, to sort of work around this at the planning stage is the wind profile calculations, as you can see there for the Isle of Mull. And then you could look at this for different wind conditions. So if you find that the operator wants to operate to say a limit of 40 knots, which CalMac we don't put a limit on like this, but many ferry companies do. These calculations, these dynamic mooring analysis, provide you with a good idea the strength of the ropes needed, the strength of the fittings needed. And you'll often find that these are above equipment numbers, because equipment numbers, whilst they address sort of windage and displacement, they're looking at basin from anchoring and standard mooring for standard ships. The problem with ferries in particular, passenger ships, is for their displacement, they've usually got a very high windage level, so it's worth investigating separately. And that basically is another nice picture. A standard spread would be 3 lines fore and aft, arresting movement in all directions. You do get some ports where you have stop fenders, different ways of coming alongside piers. We're quite limited in some ways through all the demands of different vessel types, old infrastructure, that we tend to rely on the traditional mooring methods of the lines holding positions. Worst case for a high-sided vessel is, obviously, as we've just discussed, a beam on wind off the berth. So this is where it ties into operational limits, and something, again, that's not given in build regulations, but something to find out from the end user. Just to touch on design, bringing the end user in for vessel design. Again, it's another topic that's sort of becoming a little hotter at the moment. Nautical Institute are on it. Human-centered design, the current hot topic. What we do here with the relationship between CMAL and CalMac is a lot closer than other sort of charterers and owners. We've got the same requirements at the end of the day. We're all working towards the same passenger service. We don't charter vessels from anyone else, so it forms a much closer relationship from ship design. So one of the things that we've been able to do, Dan and I, is look at plan approvals and seeing vessel designs a lot earlier on than many seafarers often do. Many turn up at the yard a week before it's due to go, and there's the keys, good luck. So sort of things that we'd be looking for: standardization throughout fleet, that affects training, and then somewhat governed by IMO regulations, build regulations, and sometimes the equipment manufacturers. But there's still a lot that you can influence even at this stage when certain equipment. And I'll just give you one final example. So this is a bridge wing console. Manufacturer proposed the one on the left. I think probably here had a lot of console space, give it a nice spread, nothing too cramped, helps for the electronics and the fittings underneath on the other side. But if you take that to the end user, you probably find on the wing, the 2 star positions are where you might stand. And this would be a starboard bridge wing. So you're standing outboard, perhaps looking through a glass floor for your final position. After being allowed to get our seafarers involved, our masters, who they found out, they fed back that we want things close together. You know, we don't want to stretch over. If you imagine the one on the left, you're standing to the side, you want to stretch across for your engines, your elbow could knock the thrusters, which could obviously have undesired consequences. So this is just a small example of one thing that you can influence early on and make a great difference to the end user at the end of the day. So I hope you didn't find that too boring or too rushed, or didn't go on too much. That's me from the deck side of things, and I shall hand you over to the real most important person on the vessel, and that's the one that keeps the lights on. So over to you, Dan.
All right, thanks, Ewan. That was brilliant. Tough act to follow, I think. I know I'd read your slides already, but blimey. It's been quite tough to bring this together whilst being apart. So we'll try and do the best we can. Can someone give me a nod if they can see my screen? Right, brilliant, thanks. Here we go. Okay, so yeah, I'm Daniel Barton and I'm a chief engineer with CalMac Ferries. I talk a little bit differently. I'm a Geordie from south of the border, and I grew up in North Tyneside. Throughout my childhood, I witnessed the demise of many of the famous names in marine engineering. Names like North East Marine, Clark Chapman, Parsons and Vickers have all disappeared in my lifetime. And we mustn't forget the Sunderland folks either, a shipbuilding town with many yards once inside its boundary, including the famous Austin and Pickersgill, who gave the world modular ship construction, and the SD-14s, all of course with locally built and designed Doxford engines, as well as J.L. Thompson's standard design, who was the basis for the Liberty ships. The rich industrial heritage present in the area helped underpin my desire to work in engineering, but being mindful of a potentially bleak future made me think that a career ashore would not be a wise move. I started my cadetship with P&O Containers back in 1996, and this was an excellent inroad into the world of marine engineering, with tangible prospects and a future almost mapped out through the structure of life at sea. I was very fortunate to experience some very old and quite important container ships, as well as see a bit of the world. And I also feel that it was a privilege to be able to attend South Tyneside Marine College when it was in its mid-20th century guise. The college was an amazing place at that time, with workshops full of operational machinery, even a real Doxford J-type engine for us to play with. Incidentally, I found out recently that one of the reciprocating steam engines that was sadly scrapped when the workshops were taken away was actually coupled to one of Froude's original water brakes. I moved to CalMac in 2006, and I've had a very satisfying and fulfilling time working here. Since 2016, I've been involved with the operational planning department, providing operational expertise to CMAL, who are responsible for our new ships' design and build. Moving to the fleet. At CalMac, we have a varied fleet in terms of age and size. And Ewan hinted earlier on that we have major vessels and smaller vessels. So we're primarily concerned with the major vessel fleet. And in that fleet, we have vessels which were built from 1984, right up to 2 vessels under construction. Here are 2 of our most sort of well-known vessels. We've got the Lord of the Isles and the Clansman, built over a decade apart to serve the same routes, but with some very different design features to enable growth of traffic and compliance with changing construction regulations without becoming too large for the confined waters in which we sail. The Lord of the Isles actually has some passenger cabins below the vehicle deck level, which became forbidden to use due to regulation changes. Some of these have recently been repurposed into a classroom and an office, and the rest have been used to support spare parts for the crew cabins as the vessel ages and the parts become hard to source. None of our vessels have any overnight cabins nowadays. When it comes to the vessels in the major fleet built between 84 and 95, they were all built in British yards using British engines and generally domestic sub-suppliers, until the influence of a foreign supply chain starts to manifest itself in the late 80s and up to nowadays, where all new ships require plant and equipment to be supplied from all over the world. Which makes life interesting when it comes to opening and maintaining relationships with suppliers, and also for myself and Ewan in this current role, working alongside CMAL on the new builds. There's some world travel involved, and that takes me back a bit to one of my original drivers for becoming a seafarer. Returning to the fleet, our older vessels primarily use the Merley's Blackstone MB275 engine, which to me is a great British success story, but it's sadly now fallen by the wayside as it's out of production. The factory is closed, and I think CalMac are probably one of the last operators of the Marinized MB275. Parts and service support is available from MAN, and as long as we can assure this, then the engines do have a future until the vessels are replaced. These engines were designed as a locomotive engine, and they lent themselves quite well to powering ships of up to 100 meters with twin screws. In the beginning, they had questionable reliability at sea, but once a device known as the flame ring was introduced, they were improved greatly in terms of reliability. The flame ring is a steel ring that's fitted to the upper cylinder liner and occupies space that would otherwise have been taken up by carbonaceous deposits that build up over time. And this can lead to premature degradation of the lubricating oil and ultimately engine damage. And it's a very simple solution to a very old-fashioned problem. Moving to some of our newer vessels, CalMac built a single vessel in 1995 to use the Merley's Blackstone K Major engine, the MV Isle of Lewis from 1995. I believe there were only about 8 of these engines ever at sea. Some of them were used on the single screw aggregates dredgers back in the 80s, the Arco A class and some of the sand boats of SCC, but they were also very popular as a prime mover ashore. Many are still in use, and I think it's quite apt that the power station at Stornoway has 6 of these engines and the old Isle of Lewis has 2. Despite their many foibles and rather old-fashioned design, they continue to provide exceptional levels of reliability to CalMac. All vessels built from 1998 onwards have used MAK and then Wärtsilä main engines. We operate 5 vessels with MAKs and 2 with Wärtsilä. All these engines incorporate the latest design features as standard, and we also now see that emissions controls are becoming standard kit and add a degree of complexity to the engine. This can also impact on machinery layout. Metallurgy too plays a big part in enabling the high peak pressures and temperatures that a modern engine requires in order to run at peak efficiency from units that are much smaller physically than their counterparts from 30 plus years ago would have been, as well as advances in lubricating oil technology, which is far superior nowadays. The older vessels are typically very simple in their outfit and operation. Twin screws, 2 main engines, 2 gearboxes, controllable pitch propellers, and generally 4 simple small gensets. This setup allows quite a good degree of redundancy for what are, in the grand scheme of things, small ships. What we're finding nowadays, which is not necessarily by choice, is that equipment is becoming more technically complex and relying on electronic components for its efficient operation. Plants such as power management and UPS systems are now much more integral to the vessel's overall safety than what they once were. If we take a look here at the Isle of Lewis, we see the engine controls, which are all pneumatic, and monitoring that is entirely analog. Now, this was not really typical of a vessel of the mid-90s, but it's what CalMac chose to do at that time. The equipment you see here matched the majority of the rest of the fleet. So I suppose that crew familiarity would have influenced that choice rather than a pressing need to use modern technology. Advancing through this slide, you'll see the Loch Seaforth, and this is typical of a modern ferry control room. The engine controls are now all electronic. The power management system is fully automatic. And here we see the use of computers to process the data from the thousands of channels that are required on such a vessel, displaying to the engineer whatever he requires to see, bringing his attention to faults right from the bow all the way to the stern. Note, however, that this guy is still a watchkeeper, and that rag in his back pocket is standard kit on any ship, regardless of age. And as chief, I just hope that he remembered to take it out of his pocket before he washed the boiler suit. My preference is actually for an analog setup, as the engineer's eyes and ears and senses become tuned into what the gauges are saying in real time. You add to that all the other human senses, and in my opinion, it trumps the computer. But the modern ship is reliant on the processing ability of the control systems to handle many inputs and give the correct output far beyond the capability of the human mind or the more traditional forms of control. This slide shows you the inside of a control cabinet from one of the main engines, from a brand new main engine. So applying this, when it comes to maintaining and understanding this technology, all my previous employers, including CalMac, have invested heavily in electrical training for us engineers, and the modern engineer has generally embraced that and warmed to the level of complexity that we're required to be able to work to on board. Applying the advance of technology to the ships of Caledonian MacBrayne, they never historically had electricians. After changing from steam to diesel, the level of technology never really demanded it. But what we're finding now is that there is a need for electrotechnical support at different levels. And we offer varying degrees of electrical and electronic training for the engineers, who can then become a little bit more comfortable when working on these systems. However, what we also find, and what I know as chief, is that the OEMs will always be required. Therefore, you need to harness and develop good relationships with the OEMs and make sure that the ones you choose for a build have good product support available. And here's a gaggle of CalMac engineers undergoing training on electronic engine controls. When it comes to fuel, all our vessels burn marine gas oil. CalMac experimented with heavy oil some time ago, but when our demand increased, the quality suffered. And as we approached the sulfur cap, we even had to go with some low sulfur heavies, but it's now all low sulfur gas oil coming from Grangemouth, Inverness and Stornoway depots, which are usually supplied by tankers sailing from Immingham on a so-called milk round. Fuel quality is really important, and we take samples every time we bunker. We actually have such a high throughput of fuel on board all our vessels that we have a special arrangement so that we can retain 20 samples instead of the required 2 years worth on board, which could be up to 100 litres of fuel to have snaffled away on board out with the safety measures of a fuel tank. Fortunately, the quality of our fuel is generally very, very high. Apart from the operational role of the engineers, maintenance is very high on the agenda. We operate an approved planned maintenance system that's bespoke to CalMac. When it comes to maintenance in service, that's not always easy, especially with the simple twin screw setup that I outlined earlier on. Here you can see 2 engineers working on an auxiliary engine. They can do this at any time of the day, as long as the work is risk assessed and the machine's locked out. The simple job of setting the tappets on these engines is not so simple, as it calls for specialist tools. Even the torque spanner here is calibrated by a specialist and forms part of our quality assurance as well as ISM compliance. Note that I state here that good lighting and access is essential, and I've personally sailed on numerous ships where it was not high on the designer's agenda and sea staff morale suffered as a result. Certainly the lads in this photo seem happy in their work on board the Hebrides. You know, the timetable demands on our company are always being challenged, and we cannot sail UMS. So running a vessel, say during working hours, must also be within rest hours rules. So any extension to working hours impacts on the time that the team have to be able to do maintenance of any substance, whether that's planned or unplanned. Here's an example of a failure that's nowadays quite rare. This is an MB275, and in this case, the simple practice of good watchkeeping drew the engineer's attention by a faint noise. This unit also started to present a higher exhaust temperature throughout the day, so we knew that we'd have to intervene at some point. Exhaust valve was becoming burnt out, and this cannot be ignored as it can be quite serious. It's so important in a case like this that the interdepartmental relationship between master and chief works. The famous saying is that oil and water don't mix. Well, you need to make them mix, otherwise a modern ship is not going to function properly. And you and Will, I'm sure, be nodding his head at this time. In this particular case, the relationship between master and it's important that the captain is made fully aware of the situation, as we may need to take action, perhaps even shut down an engine. It might even shut down automatically. And in that case, the captain needs to know what he's left with immediately so he can form a plan of action himself. Our plan of action was formed based on the information presented by the engine, and repairs were effected in good time. We had to have a little bit of contingency planning between the master, the chief, and the port staff. We actually ended up cancelling the last return of the day, albeit that would create a little bit of disruption. But the main reason for this cancellation was that my estimation of how long the job would take impacted into the legal rest hours of the engineers. So having the vessel out of service that little bit sooner enabled us to start the job sooner and be complete in time to rest prior to the busy sailing in the morning. Often a breakdown is just that, and we would never hesitate to stop the service immediately if we felt that safety was compromised. The plan worked, and the ship carried on the following day. You can see that it's a well-lit space with good access to the engine. Note also that all the lifting equipment is certified, applied with the engines back in 1988. Even though a job like this is unplanned, it still requires a certain degree of planning, along with safe working practices and the use of approved spare parts, as well as recording on the planned maintenance system. Again, essential for quality assurance. You can see here a spare parts kit supplied by MAN as part of their ongoing product support package for the aging MB275. CalMac have recently introduced an in-service maintenance group, which are specialists who have maintenance skills in the fields of electrical, hydraulic, and mechanical. They are mobile and can attend the vessel and perform planned maintenance, ideally with minimum impact to the ship's crew. And it's taken a little while to settle down, but certainly from the standpoint of chief engineer, I've been engaged with these guys on numerous jobs, and it's been, it's proven to be a really good thing. What we find is that if we were to rely on sending people up to the ships in cars and putting them up in hotels, not only would the cost of the hotels be very high, but the availability in the parts of the world that we sail is limited all year round. So these guys use camper vans, which does prove challenging, but they know the camper van is specialist kit and essential for them to be able to do their job. The chief engineer spends a large proportion of the year preparing for refit. We refit annually in dry dock. And although some of our vessels do have the facility for in-water survey, which for what it costs at build, it can actually help to reduce time required in dock. Here's a picture of 3 of our ships. The first 2 there are almost ready to sail. These are probably the sort of undocking inspection pictures. Probably not ready for undocking because the name hasn't been painted in yet. But Loch Seaforth there, she's just arrived, and you can see she's a bit weather worn and ready for a bit of a spruce up. So my time with CalMac's been amazing, and I feel very fortunate to have spent the last 14 years sailing in some really stunning locations with some fabulous, dedicated and proud crews. Right now I feel really privileged to be involved with the new builds. As you may have gathered from my introduction, I feel strongly that domestic vessels at least should all be built locally. But with the spread of the supply industry worldwide, sometimes that's just not possible. So that's my 15 minutes, and we can take some questions.
No, thank you very much, you and Dan. Really appreciate that. It was really interesting. The future of seafarers within the UK, we often hear that this as an industry is declining. Do you still see it declining, or is it stabilized or even picking up? Are people looking at seafaring as an industry still worth going into and things? I mean, do you track the younger generation, the next generation?
I'm happy to take that one if you want, Ewan, unless you've
done. Yeah.
Certainly from my point of view, in the machinery spaces, in my time, I've seen a big boom in cadet training in the late 90s and early 90s. Certainly, Maersk was advertising on buses at one time for come to sea, and that was great. But a lot of these companies, they didn't offer permanent positions at the end of the training, and I think that's a great shame. I was privileged, spoiled almost by my cadetship. We were pretty much guaranteed a job at the end of it as long as we didn't make any major mistakes, and it was a brilliant job and I loved it. But the aspects of the reasons why companies train cadets now have changed, and it changed about 20 years ago when this thing called tonnage tax was involved, which was basically a bit of a tax break for a shipping company if it was registered in the UK and employed some cadets. And I think that has kind of limited the value that some of these guys get from the training. You found a lot of shipping companies that were not as reputable as, let's say, P&O or Maersk or some of the big players, BP, have employed cadets, and they have a pretty bad time on really pretty poorly run ships, and I think that's wrong. And I've seen young guys come through recently who've had a really good time on interesting ships, seen a bit of the world, but then I've seen the effects from these guys who have sometimes even failed their exams at the end of the cadetship, and it's due to lack of experience because they've been on ships that are just not fit to have cadets on board. We have had cadets at CalMac, but we always do send them on other people's ships as well, so that they see a bit of the world. And right now, all the cadets that CalMac sponsor are actually on other companies' ships.
Right. So real challenges in some areas, but positive in others. That's good
Definitely,
to know.
Yeah.
I'm just going to ask another question before I sort of hand over back to Lewis. Regulations is something that rule all our industries in all sorts of ways, but and this is a bit of a cheeky one. Is there a particular regulation or code that just drives you nutty that you would like to change or even remove? Is something that sort of gets in your way, you think, that's over-regulated? I don't know, it's a bit of an oddball one, that, but sometimes I think we go a bit over the top with regulations. I don't know if you have any thoughts.
I'm not too sure, Dan. Nothing's springing to mind. No, I don't think any of the regulations are that tight that you can't work them. And by work them, I'm not meaning flog them and find ways around them. I mean, I think there's still an element of the British way is that we're used to rules and regulations, more so than some of even our European counterparts. I've worked with lots of guys from European countries, and even there they exist, but particularly the French, it's like, yeah, well, they exist, but I think we work well with the classification societies, the MCA flag. With us, and I don't think there's anything that I really feel is an obstruction. I think most of our difficulties, and probably the same for ferries, and I saw one of the questions flashed up actually, is fitting in with other transport networks, meeting demands. A lot of the demands and the requests that come to us are from people who might be users, very seasoned users of the ferries, but they're not, they don't have the marine knowledge necessarily. And we do find people think, oh, I've been traveling for years, I know more about the ships and the guys working on them. And that can be challenging, not to upset or offend, to make them appreciate that there's always another side of the story, whether that's financial or implications, crew hours of rest, which Dan touched on, legal requirements like that. So, I mean, I think most things that are there, they're there for a reason. We've trained with it, we've got used to it. So I don't think so.
Yeah, I fully agree, Ewan. They're there for our safety, and we use them, as tools, really. I think that the biggest challenge in the engine room department, and I can comment certainly from a CalMac point of view, is the discharge of bilge water. And I don't know if anyone's aware, but one program that CalMac's been doing recently is literally taking away the oily water separators from the ships. So basically what we do now is all of our accumulated bilge water and sludge is discharged ashore. And the reason for that is that it's almost impossible to reduce the discharge through an oily water separator to within the legal limit. It's a very, very difficult thing to do, especially on a small vessel. And from a naval architecture standpoint, a lot of the ships of our size, they have bilge and sludge tanks which are flat, double-bottom tanks, which is really bad for natural separation of oil and water. You want a vertical tank. We used to have pencil tanks on the container ships, but what we do in CalMac now, we discharge everything to a shore facility.
No, that's great. No, thanks for that. That's an interesting point about the separation. Yeah, it's and another thing that you touched on, the OCMIF guidance on mooring. It's very much on my sort of radar as well professionally, and it's something I think we're all looking at as an industry, especially the classification societies with that equipment number. It's so it's quite interesting that you picked up on that as well. I think it's something that we need to sort of improve on and look at. Okay, thank you. Lewis, can I sort of hand over to you to see if you've got any questions in to ask anybody, to invite anybody?
We've got a few, so I think there's 4 or 5 in just now. So I'll just go in the order they came in. So the first one's from Romas, and I suppose it's to both of you guys. What are the greatest safety challenges? Just a couple of them, don't need to go into too much detail, but kind of greatest safety challenges?
Should I jump in with that one?
Go first, Dan. Yeah, I can.
I think for me, as chief engineer on a smallish vessel, managing a very tight team of really well-trained professional guys, there isn't much of a safety challenge there. As long as we do everything properly, then that's great. The biggest safety challenge as chief engineer that I've had in CalMac is when we have external contractors working on the vessel. They have to be managed, and it's very difficult to do that sometimes, whether that's with the vessel in service or whether it's with the vessel in dry dock. And I've seen it. I've seen a couple of nasties, and it's not nice to be involved with, you know. And you can try, you know, as hard as you can to manage these guys, but sometimes, you know, there's always a renegade, you know. So I think external contractors is my greatest safety challenge.
Yeah, I think you know, the deck side, you get a lot with vehicles on deck, because you're relying on people that drive their car, yes, but they don't come onto ferries every day. You don't go onto a mez deck every day. And it's always quite surprising how disorientated people become. So, you know, there's a challenge always on the car deck, the safety there. And then I think the other big one, obviously, which you probably hear every time the weather gets bad, is ships cancelling. And it's making that decision of when to call it a day. Which obviously, if somebody wants to travel and you cancel, it's affecting their day, their plans, their holiday. But you know, we've got to appreciate we're looking after passengers at the end of the day. Obviously, with any ship, you don't want to damage the ship, but and cargoes obviously. But once it's people, I think you've got an extra responsibility there, and it's like, you know, there's times when you think, yeah, I could have a go at that. I'd probably be okay. But if it goes wrong, you know, so you're teetering with that safety line, I think, a lot of the time. So,
okay. So just move on. Again, we've still just got about 5 questions, so we can probably time get through them all. Next one's from Robert, and it's what are the greatest challenges to running an integrated timetable with the public transport ashore?
Guess I better do that one, Dan. I think the worst ones are when you're trying to connect with trains. Obviously, the trains have got so much knock-on further down the line. So it's become very tight over the years. When vessels get larger, they obviously carry more, so it takes more time to discharge them, load them again. And we've sort of historically stuck with a lot of existing timetables. It's very, very difficult to change timetables to suit other transport networks to meet requirements. You start allowing a longer turnaround a couple of times a day. That knocks onto the overall operating day, onto hours of rest. So it's a real challenge. And I think, as I mentioned earlier on, going back to that sort of public sector that we are, and public transport connection then is that everybody wants everything to connect by minute. Nobody wants to wait. They want to get off the ferry and jump on the train, you know, with it and be off in minutes. It's that everyone does their planning very tight. So trying to keep timetables with weather is difficult. And it tends to be that because you are kind of end of the line, you know, end of the land and going out to sea, nobody ever wants to move, you know, buses and the trains, we can't move. And because you then come to the sea, it's like, oh, the ferries can move, but you know, we're just as tight as others for other reasons. We've got crew on board that we can't just change, you know, living ashore and bring on and off so our hours of rest are very important. You know, and that's often one of the big problems we have when there's disruption. So days get extended, and then whilst we might be able to go for the weather, we're physically out of hours. And you know, we do a 14-hour day is common for a master, often longer. Particularly when the weather's bad, you feel it. It's tiring. Being on a ship when the weather's bad just physically tires you. So yeah, when you're trying to fit into timetables as well, and then obviously there's rushing to meet timetables, which has impacts on your safety then if you start rushing. So it's just trying to keep a balance on it all, isn't it, Dan?
Yeah, that's right. Yeah, everything we do, you know, like I said in my presentation, we wouldn't hesitate to cancel the service if we felt that safety was compromised. But all the time in your head, you're thinking, crikey, somebody might have a holiday book that might have cost £10,000. We just wrecked that, you know. But we're not going to take people on a vessel that's not fit to provide the service, you know.
Okay. So, Ian, how much time do you want to go on for? There's a few questions left. Do you want to do them all?
Helps if I unmute, doesn't it? Just if everybody's comfortable, just go for it, I think. Yeah.
There's 4 questions left, so and 2 are from the same person. So we'll go on to so Chris, he's got a question for he's got one for you, Ewan. He's got one for Dan. So start with Ewan. Why is your layout plan for a car truck distribution done by hand and not by an optimization tool? Does any time to complete the plan come into it? Or is it a variety across the fleet, or is it just down to simplicity?
So, to be honest, half the time there's not even a plan drawn. It's in your head experience of the vessel. You start to know the little nooks and crannies that you can get cars in, etc., and the combinations. So there is a level of sort of capacity in the system. So, you know, if you take high-sided vessels, if you take 50 meters commercial lanes, that it has an impact. So we've got coordinates in the system, so we don't tend to get booked anything unusual. So what you saw out there early, you tend to be doing that to give the new guys a help. It's like, right, put your trucks here and put them in that order, and that'll get. Where you talk about optimizing plans, I think, you know, when particularly we're coming from container ships originally, is very used to that. You've got slots, everything goes in very well. We have the order that traffic turns up in, stuff that's booked and doesn't turn up there. We maybe should police that a bit more strictly. There's stuff turning up to get on. You're relying on the ability of drivers. The number of, you know, I've stopped a car caravan on the deck once when they've come too far. They've not stopped and they've been asked and said, "Can you back up?" And the window's wound down and somebody said, "He can't back this up." And then so you're stuck. It's completely ruined your plan. You can't jump in people's cars for them. You've got to allow swept paths. And I think it's just that you start to know the maximum you can get on board, and the manoeuvring space that the cars require, the trucks require, and you learn to do better. And I think it's just, as long as you haven't got overbooked in your system, everybody's on, and very rarely do you lose spaces. And if you do, you tend to find it gets blamed on us, but you tend to find it's actually the drivers that haven't got far enough over into the lane, worry about the mirror. The door space is a big problem, particularly with the older vessels. Lots of 4x4s on the islands now, lots of Range Rovers, and you know, they don't want to go into the lane because it's too close to the bulkhead. A lot of the time it's just off on the hoof, kind of making things fit, and we find a way.
Okay, and just sticking with Chris, he's got one for you as well, Dan. So when you're mentioning a preference for the analog system, control system, sorry, for the engines and machinery, is there a future potentially of a hybrid combination of digital and hybrid, where engineers like yourself are still able to maintain the knack whilst being supported by the telemetry coming from the engines?
Yeah, that's a good point. I mean, what I'm finding as chief nowadays, certainly coming back to training as well, with the greatest respect to everyone I've ever worked with, some of the younger guys coming along from only modern ships, we have a little term for them on board. We call them the Angry Birds generation, you know, and the computer is the be-all and end-all of everything. And you know, modern ships now, even on our ferries, you can't see the engines from the control room, so you're reliant on CCTV or the monitoring system itself. So it's getting kind of difficult sometimes to like try and help these guys get the knack. You know, I was on a ship myself about 15 years ago now, and the engine started making a very faint noise. Didn't sound like much at all, but what we could see was the lube oil pressure gauge going up and down at almost the same speed of the engine's RPMs. And that's something that a digital system doesn't often pick up. It would be flashing high or low pressure based on the rate that it's measuring that particular input. But what we could see was fluctuating lube oil. So we immediately shut down the engine, and it turned out that a piston crown had come detached from the rest of the piston. If it had gone on much longer, we would have destroyed the engine for sure. So we were very lucky, you know, the company was very lucky in that instance that level of sort of sensory response was there. And I think if that was a fully automatic vessel or even unmanned, nothing would have come to anybody's attention until the big one, you know, low lube oil pressure, and that would be the end of the engine. So we always have to be mindful of the traditional watch keeping practices in the engine room, and certainly from a CalMac point of view, regardless of the amount of automation on board, we have to be fully manned because we're a passenger ship. We can't go UMS. So if the guys go and have a walk around the engine room as often as they possibly can, and learn and listen and feel what things are doing, what they sound like, what they're supposed to sound like, then that's good, because when something's not doing what it's supposed to do, perhaps it's the Mark 1 eyeball or ear that actually picks that up before the computer. So yeah, a good point there, that there has to be a balance between the two.
Cheers, Dan. Thank you. Two more to go. So next one is from Uja. Apologies if I've not said that correct. When you're talking about crew training sessions, do you think there's any knowledge gap between industry and academia? And what kind of soft skills do you think are seeking for the industry?
That's interesting. That's very
maybe a bit of both could answer that, maybe.
Yeah. I mean, but certainly my presentation there had that training session, and we were bringing together guys from all different generations. You know, some of the guys in that photograph have retired now, and you know, they don't have the understanding of some of the software, some of the ways that the equipment communicates digitally. So that was a big learning curve for those guys, whereas the younger guys, they didn't have that same sort of learning curve. So I think as far as the use of process controls in the engine room there is a bit of a gap, and I think some of the skills could be bolstered with a little bit of sort of, you know, very basic training on things like that.
Mm-hmm. I think so as well. You see, when you talk about the academic side, I think so. I did 3.5 years cadetship. A little bit over half of that would be on ships, so reasonable time at college. You see guys coming out now, fully qualified, with who've done it in a couple of years. Maybe got the academic qualification. You get degrees now in merchant vessel operations and the likes, which you didn't get before. But they're very fresh when it comes to actually being on the ship and just experiencing life on ship. And there's even sort of talk at the moment of more simulator time. And while I think there is a time and a place for some simulator time, if you compare simulators in the marine industry to the aviation industry, it's very different, because aviation-wise, you go to be a pilot and there's 5 different aircraft that you could fly on, and the simulators are exactly what you will experience in that cockpit, and we don't have that as well. So many different non-standardization of equipment, but yeah, the general sort of experiences aren't there. Dan mentioned the Angry Birds sort of guys before you. Lots of computer skills coming through with young ones. Definitely seeing it harder to communicate sometimes, which I think is something. The soft skills were mentioned there. I think historically we haven't had that sort of training. It creeps in more now with courses. Nautical Institute, again, a lot more mentoring and things going on. And these are great, but finding the time to do it is sometimes tough with your crewing levels, etc. And it tends to be sort of, you learn it over the years. So they're coming through college quickly. There's lots of them coming through college. They're not guaranteed jobs at the moment. When going back to training earlier, there's lots of training available. Although at a sudden again, COVID's hit the jobs. Unfortunately, so many, you see LinkedIn, so many with their officer of the watch ticket looking for jobs. Yeah, they spot you on there as a master and they contact you. Any jobs going, and you just have to say, sorry, you've got to apply with the pile of CVs like this that's on the marine manager's desk. It's a tough time. I think we've got to watch we don't shorten training too much there, I think, and needing the experience at sea. I certainly, 3.5 years was good. My portfolios, my academic qualifications, I got out the way early and then just learned on the job. And it's certainly, I think, there's still a good level of apprenticeship required in it.
Okay. No problem, thank you. And last question, which is from Rob, and this is specifically to Dan. Dan, Rob's asking, do they employ a reliability-centred maintenance routine to replace fittings, components before they fail, or is it more reactive with the intent of getting the ship to annual overhaul for more invasive repair?
All right, that's a good question. Yeah, we at CalMac, we operate a very, very comprehensive planned maintenance system. So basically, for every piece of equipment on the ship, there is a known maintenance routine, whether it's a pump or whether it's something as complex as one of the main engines. What we try to do is get to the refit period without having to overhaul something as complicated as a main engine. And what that sometimes means is that you might end up getting to the 2-week refit window a few thousand hours early, which is a bit of a waste of money, really. If it was a commercial, you know, a container ship or something like that, they would want to get the maximum time between overhauls. But with a ship like a ferry, where we are very, very sort of highly bound to timetables and bound to a specific time in a specific dry dock, it may just transpire that whole main engine has to be stripped down prior to its time. You would never want to go over the time, obviously. When it comes to sort of what we call condition-based monitoring, we do that now on all of our major vessels, and that is a real bonus to the marine industry. CalMac were quite late on the uptake for condition-based monitoring. It's been around for a long time. It's been around all my time at sea. What the condition-based monitoring means for something like a pump that's not maybe as critical as a main engine, if you can demonstrate at refit that it's running as it should, then you can actually defer that maintenance for a further period, and that's all approved by Lloyd's and these approving bodies like that, you know. So I'm a big fan of it. It's a very it can be as complex or as simple as you like, and certainly the simple system we use, it actually goes into the detail of how many rollers are in a bearing on a motor, and it knows what it should be listening for, and it's really very clever. And you know, if it saves you having to strip down a pump, which is not necessary, I'm not necessarily concerned about how much that costs. I'm concerned about having to get to dry dock within a period of time and have someone actually strip that pump down, where pieces might get lost or broken, and sometimes it might not run as well when it comes out of refit as it did when it went in. So if we can avoid doing that intrusive maintenance by knowing that the thing's working as it should without you know, having to take it apart, then that's a good thing as far as I'm concerned. With something like a main engine, you would never do that. You would always overhaul the engine as per the manufacturer's recommendations.
All right, thanks very much, Dan, and thanks everyone for your questions. Ian, I think that's us. Back to yourself.
No, great. Thank you very much, everybody, and thank you very much, Dan and Ewan. I really appreciate you coming on and taking time.